Dear seismologists, welcome to this short introduction to the process of event location and magnitude estimation in the HypoLine software. First, let's have a quick look at our data. You can adjust the filter settings in the top right to hide any unwanted noise. Here we see data from 5 seismic stations, verticals in white, horizontals in green. Let's jump to the station with the first arrival, Bell, to place our first peak. You can use the purple bars in the overview window to adjust the zoom of the other window. In contrast to other software, here, with each pick you place, the resulting location constraints will be shown in the map on the upper right instantly. Each combination of 2 p-picks will result in a location constraint described by a hyperbola. This is shown on the map in the upper right. As we place more and more picks, more location constraints will be shown, which hopefully converge in one point. Let's set p-picks for the other stations. Let's return to the overview showing all 5 stations. Using the green horizontal traces, we can quickly place the S picks. The P and S arrival times at each station constrain the epicentral distance, resulting in a circular constraint on the map. The lower map window shows a zoomed-in view of the map on the upper right. Now we try to find the correct event depth. As you shift the event deeper, the constraints in the maps will change accordingly. Let's find the point where all constraints meet in the smallest area possible. Now let's pick the epicenter. As soon as we do this, simulated arrival times and origin time will be shown on the seismogram traces. If you move the epicenter around, you can see those shift. Use this to check the consistency of the result and identify possible outliers. We can also utilize the 2 seismic mini-arrays in our network. Both consist of the central station shown before and 3 auxiliary stations. Here we see the vertical components of the auxiliary stations in the first 3 traces. The 4th trace shows the central station. Now we will perform a manual correlation of the traces. Pick the first significant feature of the waveform on each trace. Select the most plausible slowness estimate. This will be shown as an array beam in the panels on the right. Now we try to find the local magnitude of the event. Local magnitude is defined by the distance to amplitude relationship on a Wood-Anderson seismometer. We use the horizontal components of the S-wave. For each station, find the horizontal trace with the highest peak-to-peak amplitude. Pick the highest peak and the lowest valley of the signal. Both should be within 1/2 wave. The peak-to-peak amplitudes for each station will be plotted over distance on the lower right. Click the group of markers to set the magnitude. Now we have successfully located the small magnitude 1.1 earthquake near Basel. As you can see in our software, nothing is done automatically. We avoid black boxes and hide no constraint from the user, so this is the perfect tool where your automated methods may fail or when you have to do seismic detective work. Also, the visual approach is ideal for teaching the next generation of seismologists. Feel free to use the demo version in your classes. The demo version implements the full functionality of the software but is constrained to 4 included datasets. You can get the free demo version at our webpage sonicona.com.